Have you ever walked into a room, stopped dead in your tracks, and realized you have absolutely no idea why you entered? Or maybe you've spent 10 minutes frantically tearing your house apart looking for your car keys, only to realize you were holding them in your left hand the entire time. It feels like a malfunction, doesn't it? It feels like a system failure. It seems absurd that the human brain, arguably the most complex biological structure in the known universe, a network capable of composing symphonies, calculating orbital mechanics, and simulating complex futures, can fail to execute a simple task like, put keys on table, remember where keys are. But here is the truth: these aren't failures. Your brain isn't broken. In fact, these phenomena, which scientists call cognitive glitches, are proof that your brain is working exactly as it was designed to. Today, we are going to dive deep into the architecture of error. We are going to explore why your brain is optimized to forget the obvious, why walking through a doorway deletes your memory, and why these annoying lapses are actually the secret to human intelligence. To understand why this happens, we have to dismantle a major misconception. We tend to think of the brain as a video camera that records reality or a hard drive that stores files. But it is neither. The brain is a prediction engine. Its primary job is not accuracy. Its primary job is energy management. Think about it this way: your brain represents only about 2% of your body mass, yet it consumes a staggering 20% of your body's total energy. It is metabolically expensive. To survive, it has to be ruthlessly efficient. It cannot afford to process every single photon of light or every sound wave. So, it filters. It actively discards anything it deems stable, redundant, or obvious. This brings us to the first major culprit of our daily errors, the sin of absent-mindedness. Let's go back to the car keys. When you walk in the door and toss your keys on the table, your brain is likely thinking about dinner or an email or the dog. The act of dropping the keys is routine. It is handled by the basal ganglia, the autopilot part of your brain. The conscious, memory-forming part of your brain, the prefrontal cortex and the hippocampus, isn't even involved. There's a famous concept in psychology called the Baker-Baker paradox that explains this perfectly. If I tell you a person's name is Mr. Baker, you are very likely to forget it. But if I tell you that person is a baker, you are likely to remember. Why? Because the name Baker is just an abstract label with no hook. But the profession baker triggers associations: the smell of bread, a white apron, heat. Your brain encodes the context. When you put your keys down, there is no context. It's an abstract, automatic action. Later, when you ask, "Where are my keys?" you aren't experiencing memory loss. You never created the memory in the first place. You are trying to retrieve a file that was never saved. But what about when you look right at something and don't see it? This is where the prediction engine really takes over. Because your brain is trying to save energy, it doesn't actually see the world in real time. It runs an internal simulation of the world. If you are sitting in your living room, your brain predicts the couch, the lamp, and the rug. It suppresses the actual visual data for those objects to save power because they are predictable. This leads to inattentional blindness. In famous studies, people tasked with counting basketball passes completely miss a person in a gorilla suit walking through the scene. Why? Because the brain decided the gorilla was irrelevant data? If the world doesn't surprise you, your brain treats the obvious as invisible background noise. You are blind to it because your brain assumes it already knows it's there. Now let's talk about the most frustrating glitch of all, the doorway effect. Why does walking from the kitchen to the living room wipe your memory? Psychologists call this the vent horizon model. To manage the massive load of information we process, the brain segments our experience into discrete vents. It treats a doorway as an event boundary, a cut scene in a movie. When you cross that threshold, your brain initiates a location updating process. It says, okay, we are leaving the kitchen context and entering the living room context. To free up RAM for the new room, it dumps the working memory from the previous room. It is a feature, not a bug. It makes your brain faster for the new environment, but unfortunately, the thought, "I need to get the scissors," gets flushed away with the kitchen data. You might be wondering, if these are such common errors, why didn't evolution fix them? Why did natural selection keep these glitches? The answer is that forgetting is adaptive. Imagine our ancestors foraging for food. If you remembered exactly where the berries were 3 months ago, but the bush is now empty, that memory is dangerous. It wastes your time. You need to forget old information to update it with new information. We are built to be sticky for negative, dangerous things like predators, but slippery for neutral, obvious facts. We sacrifice accuracy for speed and survival. However, there is a catch. Evolution designed these features for the savannah, not for the digital age. This is where modern life turns these features into bugs. We are now dealing with digital amnesia, or the Google effect. We have unconsciously started outsourcing our memory to our devices. Research shows that when we know a computer will save information for us, we become terrible at remembering the actual content, but excellent at remembering where the file is saved. We are rewiring our neural architecture to be an index rather than an encyclopedia. Furthermore, the modern world exploits our brain's fluency glitch. This is called the illusory truth effect. Our brains use adhesive processing as a shortcut for truth. If we hear something repeated enough times, it becomes familiar. If it's familiar, it feels true. In the age of social media algorithms, this glitch allows misinformation to bypass our critical thinking simply because we've seen it 10 times in our feed. So, how do we live with a brain that is designed to deceive us? We cannot change our biology, but we can engineer around it. We can use cognitive offloading. First, stop trusting your brain for mundane tasks. It is not built for them. Use checklists. This is why pilots and surgeons use them. Not because they are amateurs, but because they know that under stress, the brain skips steps. A checklist forces your brain to switch from autopilot to deliberate focus. Second, use implementation intentions. Don't just say, I will work out. Say, if I walk through the front door, then I will immediately put on my running shoes. You are hacking your brain's habit of automaticity. You are offloading the decision to the environment. And finally, try a pre-mortem. This is a strategy used by top project managers. Before you start a big project, assume it has already failed 1 year in the future. Ask yourself, why did it fail? This mental trick forces your brain to stop predicting success and actually look for the obvious flaws it was ignoring due to optimism bias. The next time you forget why you walked into a room, or you can't find the milk that is staring you in the face, don't be hard on yourself. It's just your brain clearing the cache. It's just your prediction engine saving energy. It's not a malfunction. It is the cost of doing business for the most complex machine in the universe. Thank you for watching. If you want to help your brain predict that you want to see more content like this and avoid the glitch of missing our next video, make sure to hit that subscribe button.